Hi, so the question I'm asking is, can hurricanes trigger earthquakes? And it looks like the circumstantial evidence of what we've seen with a number of different hurricanes causing a number of different, triggering a number of different earthquakes, it looks like the answer to that question is yes. So I'm going to continue in this part two of the video. So this is a Live Science article about a week or two after Sandy came ashore on the U.S. coast. So there's Sandy going up the coast, and it triggered these seismic sensors. This article talks about the triggering of the seismic sensors on North America. It doesn't talk about the the three earthquakes that occurred off the west coast. I talked about them in the first part one of the video. Okay, so the fierce winds caused a vast swath of ground to shake. The ground vibrates, and this is what the new earthquake monitoring stations show. So these seismic stations lit up, so they're showing vertical movement up and down as the storm approaches Florida, right here. And then, so the earthquake monitors detected the rolling seismic wave caused by Sandy's fierce winds out at sea. The low pressure in the center of Sandy pulls up water. That water is additional weight on the crust of the earth. It's moving, so it creates these waves. The earthquake monitoring network always hears a continuous hum of background noise generated by the ocean called the microseism. Okay? But this is something else. People can't feel the shaking because the movement is very small. But these seismic instruments are the most sensitive instruments ever built, and they can detect motion on the order of nanometers. A nanometer is 10 to the is a billionth of a meter, 10 to the minus 9 meters. So movement on that scale is, of course, very small. It can be detected by these sensors. Okay, so the dense array, I mean, this is an array of them across the U.S., and U.S. array, 400 broadband seismic sensors in a grid. So they provide essentially a CAT scan of the nation. It's the first time that the data has visualized a hurricane hitting the U.S. Okay, so the pounding surf set off earthquake monitors and so on. Okay, so this is detectable now with this very fine, sensitive array of detectors. Now, so this is another article. This is Live Science. Sandy's punishing waves detected by earthquake monitor. So this is storm waves crashing on the beach. They're recorded in a seismometer in Pennsylvania. So the back and forth. So as you can see, the waves get larger and larger. This is a continuous time scan here. And you can see the vibrations are small and they get larger and larger. And this is as Sandy was approaching and generating the waves. So the heavy surf was detected. Okay, even more than 100 miles inland, the instrument picked up the power of the waves at this other seismometer. Okay, so these seismometers, of course, are there to detect earthquakes, movement of the earth, but anything causing the vibration of the earth can be detected if the instrument is sensitive enough. Okay, there was a Christmas blizzard in 2010, and these storm waves were detected, and they just thought it was noise at first, but then they noticed that it could be correlated with the time of arrival of the storm. Here's another article. The next year, there was a seismology conference. So this was presented at that seismology conference, that the seismic waves, the shaking, went clear across the North American continent to Seattle. So the hurricane's coming in on the East Coast, the vibrations are set up, they transmit across the entire country to the West Coast in Seattle. So this, this was a massive storm. Okay, if you were on the East Coast, you experienced a disaster through TV, radio, internet, phone calls, but the vibrations underneath your feet could not be detected by people, but were there. So this is a pair of geologists at University of Utah. The crashing of these waves against Long Island, New York, and New Jersey, as well as waves hitting each other offshore, generated measurable seismic waves across much of the U.S. as far away as Seattle. Okay, so this was a Seismological Society. What this doesn't do is it doesn't talk about the triggering of the earthquakes off Canada, and I'm not sure why. Okay, and there was a video here from these 428 seismometers, but the video was pulled and I haven't been able to find it. So I've got screen captures and images of various parts of it, which are in, look at the first video. Okay, so these vibrations, so it's not uncommon for events other than earthquakes to generate seismic waves. So Katrina produced shaking that was felt in California. Landslides have seismic signatures. Okay, so you know this, everything's connected. So you can have an earthquake, vibrates the ground, triggers a landslide. You can have a landslide which occurs, vibrates the ground, triggers an earthquake, perhaps triggers a volcano. Okay, so a meteor that crashed in Russia produced a shock wave in the atmosphere that hit the ground, and it caused seismic waves in the ground as well. Okay, and what's interesting is satellites here. Okay, so first of all, measurement of hurricanes. We use the Saffir-Simpson scale, which is based on, it talks about the pressure drop in the eye of the hurricane. It also is based on the wind speeds. Okay, but the energy released by a storm goes as the wind speed to the almost third power, the power of 2.7. So it's the energy of a storm that's really key for how much vibration you'll get in the earth. Okay, and so seismometers could be used, and we can use these things to track storms, energy in storms. But this is interesting. This is a turnaround. A satellite data was used for the first time to detect an earthquake. There was very low-pitched sound waves. So the earthquake occurred, the ground was shaking, there was very low-pitched sound waves that traveled from the epicenter of the earthquake through the air, and it was detected, created sort of a shock wave. Sound doesn't travel through space, right? But these satellites, there's still some air up there. So anyway, it detected some signal. The satellite data somehow detected the signal of the earthquake. So this is an interesting turnaround. Okay, so let's have a look at this. This is an article after Sandy had occurred in 2013. Hurricanes may cause earthquakes. So on August 2011, there was the Virginia earthquake shook the East Coast. Days later, Hurricane Irene may have caused more earthquakes. Okay, so here's the Washington Monument. It was damaged after the 2011 Virginia earthquake. So August 23rd, 2011, it was a rare magnitude 5.8 earthquake in Virginia. The shaking cracked the Washington Monument, toppled part of the National Cathedral, and shook about a third of the U.S. population. Okay, now from that earthquake there are aftershocks, and they taper off pretty much exponentially. But later that week, Hurricane Irene moved into the region, took out power, downed trees, and according to this new research presented at this same meeting, okay, in Nature, so peer-reviewed published paper, there were more small earthquakes that were triggered in the recently ruptured fault line. Okay, so normally the rate of aftershocks decreases with time, but instead of declining in a normal pattern, the rate of aftershocks following this earthquake increased sharply as Irene passed by, and it was published in this in the Nature article. So hurricanes, they produce strong seismic waves all by themselves. We know this. Okay, so Sandy generated shaking as far as Seattle, but hurricane triggered seismic waves. These were not. These were real aftershocks. So basically, there's a memory. The Earth is set. There was a fracture. There was a shaking. Then there's the aftershocks, and the vibration from the hurricane caused the Earth to vibrate in the same places, so that these were actually detected as seismic waves. Okay, so a decrease in pressure caused the storm's travel up the East Coast to reduce forces on the fault line, allowing it to slip. Okay, the fault system that had ruptured in Virginia has memory. It slipped very recently, so it can do it again, and it seems that Irene triggered that to occur. The idea of a natural system having memory is becoming increasingly important for scientists trying to understand natural disasters in the field of complexity science. Okay, so here's the deal. Memory is a correlation in space and time. In space and time, you can get a bunching or clustering of events due to the memory of the events in a system. So a sequence of natural disasters may not be just a coincidence. If we look at the data for floods, earthquakes, solar storms, the distributions would suggest that they're not always random events. These events can be correlated to each other if the system has long-term memory. Okay, you can have a look at the links and the details of these things. Just Google the titles and you can get all these articles. Now, so the idea is, I mean, the Earth system is a system. It's complex. There's connections between all the different elements, and there's different feedbacks between different elements. So small changes can be amplified to large changes. So, you know, when you have a highly nonlinear system, complexity is a result of nonlinearity. So the behavior resulting from interacting components is greater than the sum of the original individual component. More is different. Okay, you push something, it moves a little bit. Push it more, it moves in. It can move in a totally different pattern if you cross a threshold or cross some nonlinearity. Okay. Now, the concept that most systems are nonlinear was not recognized for a long time. Not sure why. I mean, lower the temperature of water and it stays water, you know, down to 0.00001 degrees Celsius, lower it to 0, and the phase changes and you get ice. That's a huge nonlinearity. Bend a stick a little bit, it's in its elastic limits, it doesn't deform. Past the elastic limits, it deforms and breaks. This is an interesting example, the Millennium Bridge in London. When it was opened up, crowds walked on the bridge, it started to shake, there were large vibrations, they had to clear all the people off because it was in danger of collapsing. A very light breeze blowing for a long period of time over the Comaneros Bridge set up these vibrations and the whole bridge collapsed. So this is the idea of nonlinear effect. When you have soldiers marching in step, they break their step across a bridge, because if they all march in step across a bridge, they can collapse the bridge. Okay, you know, we all know about the Japan earthquake in 2011. The tsunami was triggered, it destabilized, it took out the reactor cooling systems, the reactors melted down. So all of these extreme overlapping things are part of what complexity science looks at. Okay, and so that's a good example. The idea of a system having memory is taken here. There's more details. This is the article that was referenced from the previous article. Okay, and there's ideas called self-organized criticality. You know, the idea is that there's limits. There's elastic limits for systems, and if you push beyond those elastic limits, then you cross a threshold, you get tipping points in behavior. This is a problem with the climate system. You know, if we tip it beyond a certain level, look at the Arctic sea ice, for example, then the changes happen, and that precipitates even larger changes. So the risks are enormous in our climate system from crossing these tipping points. Okay, so basically, I've looked at. So what do we know so far? Okay, we know that there was an earthquake in Virginia, 5.8, caused shaking. We know that Hurricane Irene came along and it caused a large uptick in the aftershocks from that earthquake. Okay, we know that when Sandy was moving up the coast in 2012, off the eastern coast of the US, the seismic sensors went off across the continent and there was an earthquake off the west coast of Canada. When Sandy turned, there was a second earthquake as the seismic sensors lit up, and when Sandy hit the shoreline, the seismic sensors lit up again, and there was a third earthquake off the west coast of the US. Okay, so now we've got Hurricane Harvey, we've got Hurricane Irma associated with an earthquake, we've got Hurricane Maria associated with an earthquake, and a volcano. So the next video, the next part, will examine what's happening with those recent events. Thank you.